Good day, good people. In today's lesson, tichaita my unit vectors. That is what we want to learn. So before we get into it, let us give definition of terms. So if we want to define what a unit vector is, tinoona kuti a unit vector is simply a vector whose size tinogona kuti magnitude, tinogona kuti modulus is 1. Andika? That is what a unit vector is. Saka tiri kuti the size, if the size of a vector is 1, we have a unit vector. If we are to have an example, tikati for vector A, and if the modulus of A is equal to 1, A is a unit vector. Saka zvandabva kutsanangura ndo zvandangonyora in mathematical terms. We have a vector A. Toona kuti the size, the modulus, the magnitude of vector A ndi 1. Zvinoreva kuti A is a unit vector. Now the other thing which is equally important, kuziva kuti how can we convert vectors, kana kuti let me say ordinary vectors, to a unit vector. In order for us to do this, to transform a vector into a unit vector, we use this relation. Mfano kuti my relationships in mathematics ongoreva kuti my equations kana my formulas. So what is the relation? A unit vector is just equal to the vector in question over its modulus. Sapanapa ndangonyora kuti modulus, but manga mchikona kuti its modulus. So what it means is, tikatora a vector to divide by the size of that vector, tinowana a unit vector. That is what that simply means. Let us solidify this. Let us consolidate by using practice examples from our source material, that is Darshan K Gendah and the Nexus textbook. Our first question is going to be from the Nexus textbook. So we are going to call this our example 1. And question yacho iri kuti, given that the position vector of A or A is equal to 3 minus 2, 6, what is the unit vector? So in other terms, truda ku convert that vector into being a unit vector. So when you are answering these questions, chekutanga, you write down your formula. Saka formula yedu inoti unit vector is equal to vector over the modulus, kana over size, kana over magnitude, however you want to put it. Saka panapa mnogona kurangarira this formula muchiti vector over size, kana kuti vector over magnitude, however you want to put it. Okay. Saka panapa manje, we have the vector. It's already in column form. Korova kuti what we need is the modulus. Saka trikuda modulus of OA, which we learned in our yesterday lesson, kuti it's simply the square root of 3 squared, that is the elements inside OA, plus minus 2 squared, plus 6 squared. So this is equal to, we are taking the square root of 3 squared into 9 minus 2 squared ndi 4 and 6 squared ndi 36. So we need to know what 36 plus 9, 10, 11, 12, 13 plus 13 gives 6, 7, 8, 9. Correct, it gives 49. So panapa this is equal to the square root of 49, which means our size is 7. Mazona. Saka that is going to be our size. The size of that vector is 7. Taona kuti the size of the vector is 7. Takuchida uchitsvaga the unit vector. Sateta ngoti unit vector is equal to vector redu ndiani ndi 3 minus 2 6. Then this is over the modulus, which is 7. Now from here zvatinoita tichati this is equal to 7 inoiti toda kuconverta that division case into a multiplication case. So what we simply do is tinongoti 1 over 7 ndiyo iri kumultiplier, ndiyo scala iri kumultiplier 3 minus 2 6. That is what we do. What is the inspiration there? Let us say, for instance, tina, let me use a different color, tina 4 over 2. Instead of dividing 2 into 4 directly, tinogona kuinyora is half of 4. Panapa tikati 2 into 2 1 into 4 ndi 2, tikati futi half of 4 tinowana futi chi 2. Saka is the same effect. Saka zvataita apo tangobva from division to multiplication. You can actually do it the long way, which I do not encourage, but just for the sake of learning, this can be done the long way. And what is the long way? Long way ndeyekuti munozodai so 3 minus 2 6 dividing 7, then madaro mozoti this is equal to 3 minus 2 6 multiplying. Remember, kana chiconverter from a division to multiplication tinopidigura 7 the divisor. So inongodzoka pa 1 over 7 multiplying 3 minus 2 6. So you can do it the long way if you are more comfortable with that, but that is simply a precise shortcut. Okay, saka after taona kuti that is how we are going to express it, takuchingoita scalar multiplication yatakadzidza, which means this 1 over 7, alright, let me use the color I was using originally. So it means the 1 over 7 is going to multiply 3, the 1 over 7 is going to multiply minus 2, and the 1 over 7 is going to multiply 6. So our final answer is simply 3 over 7 minus 2 over 7 and 6 over 7, like that. Saka this is the unit vector. That is how it is done. You see, it's wonderful. Let us go on to other examples. Example yedu iri kuti find the unit vector in the direction of 12i plus 5j. So the vector we are given panapa, it's 12i plus 5j, like that. So tinoda kutanga tanyora this vector in column form. Remember tinongotora ma multipliers kana kuti coefficients kureva kuti tinenge tina 12 5, like this. Saka kuti tiwane the unit vector in the direction of 12i plus 5j, tinotanga tanyora formula yekutsvaga unit vector, which is simply vector over modulus. Kureva kuti automatically we need to find the modulus of 12.5. And kuti tiwane the modulus of 12.5, this is just equal to we take the square root of 12 squared plus 5 squared. So what is 12 times 12? 0, 2, 1, 4, 2, 4, 4, 1. It's 144. And of course, the square root of 5 into 25. So if we add these two, tinowana 9 panapa 4, 5, 6, then 1. Then tikauya tikada kutesta 13 times 13 kunoku. Muchaona kuti 3, 1, apo 9, 3. Muchaona kuti answer ndi 169. Kureva kuti panapa tichiti this is equal to the square root of 169, which is 13. Kureva kuti our size is 13. Taona kuti our size is 13. Allow me to do this to demarcate panapa. Teacher vatata say zotawana size unit vector in the direction of that vector ingeri equal to the vector itself 12, 5 over its modulus 13. We are going to write this as 1 over 13, 12, 5, which eventually kana tikada kuita factor in ingeri 12 over 13, 5 over 13, like that. That's our unit vector. Now pakunyora final answer yedu, even though this is not wrong, it's mathematically correct, but convention kureva kuti zvinoita mathematicians akawanda kunyora answer yedu in this form. Saka patinongosvika pana 1 over 13, 12, 5, we write our answer, unless our scalar ichipinda inside the vector and altering stuff. Saka zvandokurudzirai panapa ndo pano kumira our answer. But concept maona kuti inoitwa sei, and I'm sure that it's relatively easy. Let us go to the second example, which is our practice question. As for our practice question, second practice question, iri kuti find the unit vector in the direction of 2i plus 2j plus k. Remember, kuti tiweke zvakanaka, we should convert this into column form, and it's going to be 2, 2, 1. Then toziva kuti a unit vector is equal to the vector over modulus. Saka, this is what is our modulus. Tauda our modulus. Saka, we can say considering modulus, just to communicate our answers more efficiently. So to consider the modulus, what are we going to do? To consider the modulus of 2, 2, 1, we know that it's equal to the square root of 2 squared plus, my brackets and ones of kumasiya, they protect me from a lot. So 2 squared plus 1 squared. So we know that this is equal to 4 plus 4 plus 1, which is equal to the square root of 9, which is 3. Saka 3 is our size. Now kanata kuchida apply this formula, we know that our unit vector is now equal to 2, 2, 1 over 3. And for our final answer, it's just a third of 2, 2, 1. Third ikapinda mukati me vector create ma fractions aitisire an exact answer. Saka we leave it at this. So that is all about unit vectors. Let us further strengthen this idea with another example. Our third and last practice question, the iri kuti, if OA is equal to 2i plus 3j plus k, yobva yati saka ndobva ndatoti manje kana ndichiverenga ndoziva kuti ndiweke zvinhu ndinofanirwa kuzviita zviri in column form, saka ndinobva ndatongodai so this is going to be taking coefficients 2 3 1. ndobva taudzwa futi kuti OB which is equal to 3i minus 2j plus 4k, it's equal to, in column form, the 3 minus 2, 4. Find a unit vector in the direction of AB. Saka, chekutanga, tirikutoda AB yacho. So AB equal to chi, destination point OB, kwa gumira vector, subtracting kwa tangira chi, vector. Like that. So this is equal to, what is OB? OB ndian the 3 minus 2, 4. Subtracting, what is OA? OA taken out in the 2, 3, 1. So this is equal to 3 minus 2, the 1, minus 2 minus 3, the minus 5, 4 minus 1, the 3. Like this. Saka taona kuti AB ndiani, we know kuti tikuda kuzotsvaga a unit vector, and a unit vector is given by this formula, vector over modulus. Saka panapa takuda kutsvaga the modulus of AB, which is equal to the square root of 1 squared plus minus 5 squared plus 3 squared. And this is equal to what? Square root of 1 plus 25 from minus 5 squared plus 9 from 3 squared. Saka panapa tikati 1e andi plus this 9 gives 10. 10 plus 25 then the 35, and we do not have a perfect square. 35 is not a perfect square because we don't have an exact square root of 35. So we can actually leave it at that. So therefore unit vector atrikuda in the direction of AB renge equal to the vector itself over its size, which we know is just 1 over square root of 35, 1 minus 5, 3. That will be our final answer. So kana tadai so amani shamwari, tinenge tatopedza ma unit vectors. In our next lesson, tichatarisa how to find, kana kuti we are concerned with angles between vectors. Remember zvatakataura patakaita dot product kuti the sign of the dot product, be it a negative, a positive, or even 0, tells us something about the angle between the vectors. So we are going to be doing that in depth in our next lesson. If these lessons are helping you, may you please consider subscribing, liking, sharing, commenting, joining to support us. If you are interested in joining our class, our school, you can WhatsApp us on these following numbers. We are available via WhatsApp. Otherwise, thank you and take care.